Okay, so we just looked at an example of exponential growth on the left here, where our function grows as we increase our inputs. And then we looked at an example of exponential decay, where we start with large outputs from the left, and as we increase our inputs, or in other words, as we move to the right on the x-axis, our outputs actually decrease. So we get this sort of opposite behavior, the same general curve, just with an opposite orientation. And again, notice the horizontal asymptote in either case at y equals 0 and the y-intercept at 0 and 1. So let's look at some transformations on these graphs. Transformations definitely are not going away. So we have this. We have these parameters for transformations that we learned in chapter 2, but we're going to do a little name change here for these parameters. Nothing really is going to change other than what we're calling these parameters. We're going to look at the parameter c here, and we know that this parameter c is our horizontal, it's our horizontal shifting parameter, and that's not going to change. But what we will change is what we call it. We're going to call it h now. Instead of calling our horizontal shift parameter c, we're going to call it h. And the reason for this is because with exponential functions, we are, at least for this particular class, we are representing our base of our exponential. We're representing our base with the letter c. And we don't want to get confused, right? We don't want the letter c to represent two things. We don't want the letter c to represent the base of our exponential function and the horizontal shift. That would be so confusing. So we are just going to change the name of our horizontal shift parameter. And just for a little bit of symmetry, we are going to also change the name of our vertical shifting parameter. For vertical shifts, we are simply going to call them k, because I don't know. I actually don't know why we typically call it k, but c and d are common names for horizontal and vertical shifts, and h and k are also common names that we give to horizontal and vertical shifts. So just note that change. So our parameters for our transformations will now look like this. Y equals a times f of b times x minus h now, all plus k. So note those changes. And if we introduce those parameters directly into our exponential function, then we could write our exponential function like this. Y equals a times base c, all to the power of, because our input for exponential functions is in the exponent, all to the power of b times x minus h. So that's where our input parameters go. B controls our horizontal stretches and reflections. H controls our horizontal shifts, and those will always live in the input of your function. And then we have plus k on the outside here. So that's what our parameters look like when we introduce them directly into our exponential function. And this is what our parameters look like for any particular function that we like. So this is more general. Could apply to any particular function. And this is more specific. Specific particularly to exponential functions. All these parameters do all the same things that they did in chapter 2. Parameter A, we already ran over the vertical and horizontal shifts, so parameter A is a vertical stretch. And remember that if A is negative, then we have a reflection. about the x-axis. So the x-axis is what is acting like a mirror there, and the y values of your graph all change their sign. B is a horizontal a horizontal stretch. And if B is negative, then we have a reflection about the y-axis. So the y-axis is what's acting like a mirror, and your x values of your graph will all change their signs. Okay, so these will be some powerful tools for controlling and modifying our exponential functions and their graphs. And for this particular example, what we're going to do first is just sketch the graph of y equals 2 to the x, which we've done in a previous example, so that won't take too long. Then, using transformations, sketch the graph of y equals negative 2 to the power of x minus 1 all plus 1. And we're going to do this in our next video.